Here we have AP Calculus AB problem. Okay, let's go with the information. A piece of land is shaped like a right triangle. Two people start at the right angle at the same time and walk at the same speed along different legs of the triangle while spraying the land. If the area covered is changing at 4 meters square per second, how fast are the people moving when they are each 3 meters from the right angle? Okay, first let me draw a right triangle. Here I have drawn a right triangle ABC and we have right angle at the vertex A. So according to the question, the two people start at the right angle, that is at the vertex A. So one person walks on the leg towards the vertex B and the other person walks on the leg towards the vertex C over here. Okay, now I assume the distance covered by the person who walks on the leg towards the vertex B as x meters. So what is the distance covered by the person who walks on the leg towards the vertex C? So that is also same, the x meters, because the question says both the people start at the same time and walk at the same speed. So whatever distance covered by the first person is we have the same distance for the second person as well. Okay, and also the question is asking us to find how fast are the people moving when they are each 3 meters from the right angle. That is when each person is away 3 meters from the right. Let me write the stuff over here. So when each person is 3 meters away from the right angle, so how fast they are moving. So it is given by the derivative of this x, because they are asked us to find how fast this x is getting changed, because we have assumed this x as the distance covered by each person. So if I want to find how fast each person is moving, I just have to get how fast this x is getting change with respect to time. So that is given by the derivative dx over dt. So more specifically, when x equals to 3 meters, that is when each person is 3 meters away from the right angle. So how fast the people are moving, that is given by dx over dt. That's over here. Okay, now we have some information about the area of the triangle. That is not exactly area of the triangle. So they're given the information how the area is getting changed with respect to time. That is 4 meters square per second. Since we have some information about the area of the triangle, so first we can write the area of the triangle. The formula to find area of a triangle is going to be 1/2 times base times height. So here A equals to 1/2 times. So the base of the triangle is given by x, and the height of the triangle is also given by the same x times x. So then we get A equals to 1/2 times x is x square. Okay, since we have the information about how area is getting changed, we have to find the derivative of this area, because if area is getting changed, it means that can be attained by finding derivative of area. So now, and also the rate of change of area is given with respect to time. Since the rate of change of area is given with respect to time, we have to find derivative of this A with respect to time. So now let's find the derivative on both sides of this equation with respect to time. When I find derivative of A with respect to time, I'm getting dA over dt. And here 1/2 is a constant multiplied by the variable. I keep the constant 1/2 as it is. And so whenever I find derivative, if there is constant multiplied, I have to keep the constant as it is. Okay, here when I find derivative for this x square, first I have to find derivative for this exponent too. So for that, what I have to do is I have to use a power rule of derivative. Power rule means I have to bring this exponent in front of the variable x and subtract 1 from the exponent. So in that case, I'm getting 2x to the power of 2 negative 1. So 2 negative 1 is just 1. Whenever the exponent is 1, we don't have to mention, we can leave it. Okay, now, so I computed derivative only for the exponent 2 over here. By chain rule, I have to do further derivative for this x with respect to t, because on the left side, I have done derivative with respect to time. So in the entire equation, I have to do derivative with respect to time t. So now by chain rule, I have to do derivative, further derivative for the base x with respect to time. In that case, I'm getting dx over dt. So this 2 and 2 will cancel out. So I'm getting dA over dt equals to x times dx over dt. So here this the dA over dt gives how fast the area is getting changed, and this dx over dt gives how fast this distance covered by the person is getting changed. That is how fast the people are moving. This is what given by this dx over dt. So we have to find dx over dt when x equals to 3 meters. That is when each person is 3 meters away from the right angle. Okay, now let's plug in the values for this one and this one. So value for this one is given. That is how fast the area is getting changed. That is 4 meters square per second. We can plug in this 4 for this dA over dt. And for x, we have 3 times dx over dt. Okay, now our aim is to solve for dx over dt, so that we have to get this 3. For that, I divide both sides by 3. Then this 3 will cancel out. I'm getting 4 over 3 equals to dx over dt, or it can also be written as dx over dt equals to 4 over 3. Actually, now we have to write units for this one. So here in numerator, we have the variable x. What is the unit of x? It's meters. So what is the unit of time? It's seconds, because according to the information we have over here, 4 meters per second. Okay, so since the unit of x is meters, we have to write meter in numerator. And since the unit of t is seconds, we have to write seconds in denominator. So therefore, the people are moving at the rate of 4/3 meters per second.